Okay, I will hit the screen like this, and I will do my best to follow this one. This case, because it will be more focused on the results, you can come to sit here if you want. We are not using the computers at this moment, so if you want, you can come here to see better the screen. Okay. If or you can join, because there is a meet here. You can join the meet if you want, or just come here and then come closer. Okay. The exercise was to do the same exercise, changing the angle from 30 to 60 degrees. Okay, so let's go through to see where we have the change. And changing the axis here to, in this case, to make it the same as here. Okay, it was in this case. In this one was making these two changes. Okay, so one of the difference here is if how would be the new configuration? So the new configuration would be pretty much the same. The main ones remain the same. The capital letters remain exactly the same. What the difference will be in this case? Okay. The difference will be in the lower case, which would be if we follow the same as the example, and then the x will be the other way. So the z and the y, and then in this case, the x will be the positive, will be going the other way, the other direction. So that means that, okay, thank you. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and those who are here already, who came last week, you put yourself as well in the day, did you? Okay. 3 people now who came last week. I think there were more last week, more than 3. So probably the others have arrived. Okay, so this would be positive. The y and z would be in the same aligned to the y z. No, I'm doing something wrong. Z and y. Okay, now, so it was done to maintain the same reference as the main ones. So you maintain the same reference. Will you change the y over here, and then you rotate the other one to maintain the similar directions, just like here. Z, y, x. So in this case, this would be now the z. It's only the only difference is the reference that you have. So in this case, it would be z, and this will be y. But you have the z and the y. In this case, basically what you do is just you change everything to the new axle, and then you define the same changes. You define the same changes in the y, and the clue But the key point here is changing the lower letters where you must. So in this case, in the lower letters, which would be the new letter here? This is lowercase. So this is from the angle from the axle to change. So the only thing you do in this case, you interchange, and that's it. So this would be J, and this will be K. That's the only difference. And you interchange as again here. And that's it. Until here is pretty much the same. Here, so this, what happened? There you are. Okay. There you are. So you change. So you interchange wherever you have it. And here would be the same. I'm changing these two. And then it would be 0, 0, and then you interchange the values. So what would happen? That here, it would be pretty much the same, but what would be the difference? Because you did this. The one who was plus now is minus, and the one who was minus now is plus. So it's the same, but with a different sign. Is that correct? Because you do like this. Yes. Let me check that. Yeah, sorry. Okay, we have been. Let's verify here. Okay, and the magnitude. Yes. Yeah, okay. Yes. Just a minute. Now the first one is use if you don't change the angle, and it would be, and in this case would be the same, and this is with 30 degrees. Okay, so if we only interchange the axles, what we would have is the same value. We are not changing the angle here. We are maintaining the same angle just to have the example. So we don't have, we have this plus, we have the same axle. Now this, is it coherent? Well, let's go back to see the difference. We said that if we interchange the axle, now the x would be positive, would be the other way around. So if we say that this would be a positive, and before was negative, does it make sense? Where is the direction of the new vector? We are not changing the angles in this case. We're maintaining the same. We're maintaining the same angle first, 30 degrees. If now this is positive, why this one is positive? Which is the direction of this vector? Is coming towards us, or is going towards the screen board? This is why. Y is the axle X, positive. This is positive, so which would be the direction? Towards us or towards the screen? Is the lower letter case. Which would be the direction? Following this new configuration. Towards the screen, inside the screen, because this is the positive that we had defined. And why is this positive in that direction? What's the reason for that? The right-hand rule. In the right-hand rule, you also have this configuration, the YX set, and if you change it, you can do that. But if you do it, then what was it? No, what was different in the positive ones is yes, Y and Z. This is how I resolve it, and this is how it is now in the screen, because we modify this to make it fixed to this one, to the lowercase. This is the uppercase letter, lowercase letter. Entonces, Y es minúscula. Cambiamos el sentido de los ejes. Por lo tanto, para que quede acorde a la regla de la mano derecha, de acuerdo a las convenciones, entonces la X minúscula ahora queda detrás. Cuando rotamos esto, cuando la Y lo ponemos aquí y la Z lo ponemos aquí, entonces para que cuadre, tenemos que rotar X. Es la única manera en la cual puede cuadrar. Aquí no estamos cambiando el ángulo, estamos dejando el ángulo 30. Cuando tenemos el ángulo 30, antes era negativo, ahora es positivo. Eso significa que si es positivo, entonces va en el sentido positivo de nuestros ejes. Por lo tanto, entonces, esto va en el positivo. ¿Ok? Ok. If you compare with the other result, it was the same, because before the negative was the other way around. Before, it was the same as the lower uppercase letters. Now, is the lowercase in the other direction. That's why. So this is something which might look trivial, but it's not. It's not. Okay? Well, now, second, if we now go to the 60 degrees, from this, the question is, which of those will change? We had omega, the two omegas. Omega sub 0, and then we had the addition of these two. Which of these two will change? And when we change the angle, the omega this one will change. But the question here is, when we calculate with the new angle, the magnitudes of these two vectors will change. We will have something like this. This is omega before 0 degrees, and you will have something like this. Now, omega is the same, but the angle is 60 degrees. And then we have, this would be, it was y before, and this was z, and now this is z, and this is y. So these values, they change. These two. And we will be according now to the value. So, which will be the new value? So what you do is you define this is 60 degrees. So it would be the same as if it is 30 degrees. So you will have something like this. And this is something I like to do because to make sense with this. And this is Z, and this is Y. So this is Z and this is Y. So the one here in Z would be sinus or cosinus. Would be omega cos 30 degrees, and this is omega sin 30 degrees, and this would be omega a half so you will interchange and they will have addition. This would be one. It would be one, the omega, and then omega sub 0 will change. Omega sub 0 is in Z, positive. This vector will change, or it will be the same. Yes, but there's one thing. The magnitude is the same. The direction is the one that has modified. So you will have now 60 degrees. But the magnitude is the same. And the axle rotated together with angle. Therefore, that means that when you make the addition of these two vectors, the omega sub 0 is the same. And would be in the axle, the Z. So this would be, what was the value? The value was 4p. 4 pi in Z, lower letter. And this would be the one we set here. In Z, omega cos 30 degrees in Z. We should define if it is positive or negative. It's positive in both. Plus omega. And let's put in cosine would be square 3 divided by 2. And in Z. And omega a half in Y. And this is Z. Okay. It should be interchanged with the previous result. Okay. Okay. Pi plus K and Y. And this is an omega. What was the value of omega? 2 pi? Okay. So in this case, it would be 2 pi. Not working. Let's try again. Sometimes that happens with it. I will have to close this one, open it again. Let's see if that works or not. Okay, yes. Okay, so it's the 2 pi, and here is 2 pi. Therefore, when we make the addition of these two, it would be 2 pi square 3 pi plus 4 pi in k plus pi in j. It would be the value square 3 plus, and the difference is that these two would be in different axle. Okay, and then we can also put the pi here outside, and that's it. Okay, good. So we have these two, and now the only difference after that is the values. So we put the values here, the omega, these two values that we have here. The omega, the capital letter, and the lower letter, we put the values where they correspond. So the other one would be something like this. It would be for the alpha, the y is 0, 0 both. Omega first, it was 2 pi. Was square 3 pi in k plus pi in j. So we put those values here. J pi and in set we put pi square 3 plus 4. And in the other one is omega, which is pi in j, and square 3 pi. Okay. So for 30 degrees, we have these three. And then we solve this value to get the acceleration. The only difference here, the only difference here is the axle and the values for each of the two vectors. That's the only difference. And we put the corresponding y, j, z where they correspond, and that's it. This one was used making the same all the time. Velocity. Yeah, it's exactly the same, only changing. That's why the magnitude will be different. When you change to 60 degrees, you change the magnitude in two of them. Okay, velocity. The velocity, we got y cross vector or a. So in this case, it changes the same. the y. And this is one of the interesting things here is this vector will change from O to A. Yes, but one of the key points here in the analysis is you got the 0 here, and you got the A here, and now it was the set. This is the set, and this is the Y. Here you had 60 degrees. So that will depend if you are working in the uppercase letter, uppercase axle, or the lowercase axis. That depends on that. So if you are working in the lower changes, it won't change. It won't. Yes, it won't change because you're maintaining here, but this is the axle which is rotating, which is changing. So in this case, you will maintain the same two values. I am talking about this, the vector R. The vector R will be the same. Whether it's 30 or whether it's 60 degrees, it will be the same. Yeah, the degrees, yeah. The R. But the J and the K are going to be different. Yes. Now the J and Z are different. Now it's J is K. That's right. So in this case, it will be the same value, but here you put in a different axle, and that's it. But the values will be the same. The values are the same. Okay, so, and the omega will also be different because in this case, the omega is the one we had just calculated. So in this case, the omega will change both. We change the axle and we change the magnitude. So one of the things here is understanding, depending on which axle we are using, will be the values that will change or not. And then we're changing from that axle to the other axle is when you see the difference. So in this case, it would be pi j, the omega, pi in j plus pi 4 plus square 3 k. That will be the value. So, and then you only have to multiply the two values. And then when you do the square, what do you have? I didn't calculate it. Where is one is okay. Any of here? Do you have the result? I thought I had calculated, but I didn't have the final one. Okay, let's put this here, the values. Okay, so it would be the same. 0, 0, and y, j, pi, and k, pi 4 plus square 3. And here it would be the same, 0.25, 0.125. Okay, so, and then we have 0.125 pi minus 0.25 54 plus square 3
minus 1.465.
465 in J. J. Hold on. Sorry. Why? No, but this is the final result you have. Okay. So it would correspond to this. This plus minus this thing. And then you got this value. Why? And this is meters per second. So this is a slightly different that the other one. Why is the difference? Because here we also have a different magnitude. Okay. Now the other one is and the final here is velocity in A and nothing more. Okay. Okay. So you have this value, and this is the same y, and this is negative. And the other one was positive or negative? In the previous one. The previous one positive. And this is negative. What's the meaning of this? This one goes in the same direction or is in the opposite direction?
It's in negative direction because the circle is the point of the circle is coming to you.
Yes, but this is in the y in the lowercase letter. So if it is the y lowercase letter, it means that it goes.
Yes, for sure, but the medium of the great letter because the axis x doesn't change.
Yeah, but then that means that this would be same direction as before, or not?
Yes.
It's the same direction that before, for the same reason as we said before. For the same reason that we said. Now, the plus is going towards the screen. Previously, the positive was going in the opposite direction. So if this goes negative, it would be the same. This is x. Therefore, it would be, okay, it would be this direction. In the previous exercise, it was positive because the x negative, the x lowercase, was positive in this direction. And now it's in the opposite direction. It means that it's the same than before, the same direction, the vector. So these kind of things, it's important to understand from the point of view when you are solving this. Where is the positive? Where is the negative? We are going to analyze this problem later in motion, and then you also will depend on where is the positive and where is the negative. And the motion defines a positive and a negative, and everything must be according to the positive and negative. That's why it's important to understand this. Where is the opposite? Where is the positive? Where is the negative that you are defining? Okay. Now let's go to the other one, which was more difficult. Okay. Here, when we have this configuration, now it's exactly the same as before, with 60 degrees. So the only difference point it would be at 60 degrees. Okay, now let's analyze the overall equation. Where is the 9.7? Here, at the acceleration. Okay. So the first thing is velocity in B is pretty much the same. Where we are going to have a difference? In this case, we are going to maintain the same axle. We are not changing the axis in this case. So in this case, we are just maintaining the same axles, only changing the angle. So we have this. We have 2 points. We have the point O. And then we have the other point, which is the point. Okay, this is another point, which is B. And from the point B, there is another one, which is the A. This is like this. And it would be the A. And in this case, Y, where we have the omega sub 0. And we have the other omega, which is NZ. Okay, so we have the two values. Omega, it doesn't change. The ROV is changing this value when we are changing to 60 degrees. These are not changing. These are the same, because the only change we have is 60 degrees. So this is pretty much the same. So the velocity B is given by this direction, is the same, whether this angle has changed or not. So this will be the same. Then we have the other segment, which is omega cross R A to B. In these values, any of these will change when we rotate to 60 degrees. When we go to R A B, this vector is changing. When we go from B to A, when we change from 30 to 60, we have a change, because in the 30 degrees, we have this, and in the 60 degrees, we have this. So the vector that goes from B to A has changed, it's different. And now we must identify in this, which would be the values. The values J, K, but we must identify, this is the Y, and where is this other one? Here. The question here, if you go to Y and K, where is the difference? When you went from 30 to 60 degrees. Yeah, but you change the angle. You change the Y is the same. Y and Z. In Y, here you had 0.3, and K, you had 0.12. Which would be the new values? Do we have new different values, or are the same? It would be the same values. And in the case of omega, we do have a different values. Why? Because the same reason as before. This is the omega. And this would be the same, exactly the same. 3 degrees. And we had 60. You had different values. The omega is the same. The omega doesn't change, but this will change. These two values will change. It's exactly the same as before. So in this case, it would be, he will be cos and he will be sin. That's the difference. So therefore, you interchange here. These two will be interchanged. So the point and 60 degrees. No, it's the same. If you put the sinus or cosinus, it's the same as you changing sinus from 60, so it will be the same. So it's equivalent. Or yeah, so it will be the same. So in this case, what we have here is 0.36 mega plus RAB. It would be 0.36 square 3 divided by 2 minus 0.9 1 half. And both is in Y. And we have, what's the result of these two is minus 0. What? 15, 8? It's because I have this, but I didn't. Okay, give me one number by number.
8, 2.
Okay, and this is in Y, the same. Minus. Yes, and this is in minus. So it would be the value of omega cross RBA. And here, therefore, this is, okay, this is the same value. So in this case, the relative velocity. Do we have any change here? Have P?
Why the relative velocity is this equation?
This one? Radius? This is the distance between A and B in this axle. So if we go back to this configuration, we should define between A and B in Y and Z minus in the lower ladder. If it is lower ladder, so the distance you have. So the distance that you have in this exercise is 0.3 and 0.12. So if you walk, you will walk 0.3 from this to here, and then you will walk 0.12 from here to here. If you got B to A, you will walk the same distance. If you have 30 degrees or 60, you will walk the same. If you go from B to A, which is different to going from 0 to B to A. So that's why the difference in this case. And where is this one here? And in the case of the omega, when you get omega, when you modify this angle, the distance that you will travel will be also different in one and the other. So in this case, since we are using the same angle here, okay. So in Y and Z, RB would be the same as we did before. Where is this one? Here, the one that we said here. Where is this one? RB. 0.3 and 12. Okay, so in this case, where we were here. So do we have any change in this velocity? we don't have any change in velocity because relative to this, there is no change. The vector is the same, velocity is the same, and the distance that you walk on this axle is the same. So it would be the same as before. Now, we got the relative velocity. And we got the velocity in A would be velocity in B plus omega cross RAB plus velocity, relative velocity. So in this case, the difference would be only in this one, because these two are the same. So in this case, we have minus 0.13823. And therefore, velocity in A equals minus 0.22823. And Y in meters per second. In this case, we are maintaining the same angle. The only difference is because when you change the relative velocity, but only of one element. So one of the things here is to think about this exercise is which are changing and which are not changing, and why. And over here in the acceleration, what do we have in the acceleration? This is the same. This is not changing. And the velocity in B from these three in the capital letters, which one is changing? Is any of this changing? Or is the same? Do we have any change in the velocity in B? The velocity in B was the same. The omega was the same. Therefore, in this case, would be the same as before, because there was no change. And if we go later to this is with OV, and we go to AB in capital letters, do we have any change here? The distance AB in capital letters, yes. So which one will change? Which would be the value here that we change from this? Here, any change here? No, because it's the same. We are working in the capital letters ones. And here, any change here? Which one will change? Which one? This is because this is the value that we had calculated before in Y, and then in this case, it will change from minus 2 minus 0.13823. And then here, this will be different. Why is difference here? Because it's relative from AB, and we are working in uppercase letters axles. That's the reason it's changing. If you solve it with the lowercase, si lo resuelves con el de minúsculas, será diferente. Why is changing? ¿Por qué cambia? Esta es la que había, porque esto es relativo de A a B y estamos calculando en IJK. Estos a su vez, cuando lo calculamos antes, también da diferente por lo que hemos dicho, que es relativo. Entonces, it's very important to consider which is the relative ones and which axle we are working. Okay, so in this case, it would be minus 1.03823 in y. Yep, this one. So this would be different. And then here, in Coriolis, do we have any change here in Coriolis? Here, any change? Here's the same. So some of them will be the same because there is no effect depending on which velocity are changing and which are not changing. And in this case with P, do you have any change here? In any of these values? It's the same. So one of the important things for me for this exercise is to think which of these are changing and which of these are not changing. So the final one, here we have, this will be the same. This is 0 because it's constant velocity. So it will be the same. Which will change here? From this, which of those will change? From these values, which are changing? Which we have any change in the calculation? Which one? Leather acceleration in B. And where is acceleration in B? Velocity in B. Okay. Acceleration in B, both were the same. Therefore, it was the same. No changes. Acceleration, normal acceleration due to the rotation in omega, you had a change. So here is different.
One question.
Yes.
I don't remember. Why don't we have tangential?
Ah, yes. Okay. Why we don't have the tangential? Okay, because if you remember here, this is circumferential velocity. So if it is a trajectory, which is in a circle. So in a circle, you have two types of acceleration. One is the normal, and the other one is the tangent. And then, depending on how it's rotating, the acceleration that you have here. So this will be present all the time if it is a circle. And the other one will be present if this is accelerating or not.
Okay, it's constant.
Because it's constant, this is 0.
We are not going to do without constant.
Okay, we are making it simple now because we don't have to complicate it. But if you had these systems where increasing the if we increasing the speed, then you will have to add this tangent. Okay, that's the reason for that. And this normal, which is omega square radius, will be present all the time. Why is present this all the time? Why AN is always present? Why? Anybody here who can answer this question? Why the normal is always present? The tangent is not. The tangent acceleration is not present all the time. The normal is all the time. Why? What is the reason for this to be present all the time? Any? Why? Yes, but there is another centripetal versus force. Yes. Yes, but there is another, depend, okay, let's put, if you look in the way of trajectory, if you think in terms of trajectory, how is this trajectory? Circular. If the trajectory is circular, you must have this value of acceleration to make this trajectory circular. That's the meaning of that. That's why you need it. What happens is like in the David and Goliath example. If you cut this rock with a rope, it will be circular. The moment you release it, what happens? What trajectory will have? It will continue tangent, but it will continue. It will not go. It will not change the direction. It changes this direction in this way because of this. And that's why all the time goes towards the center. Because it's the one that makes the change in the trajectory. Okay? That's the reason for that. And that's why it must be this value to make it circular. Okay. Yep. So we go back just to the final solution. And then the only change that we have is this value, which will be minus 1.0382 in J. And therefore, the final value will be we change here 5.411 is in J minus 6.651 in K. And then the absolute value of A will be square 73.523 8.5743 meters per second square. Okay. Any of you had the same result? Yep. Okay, perfect. If you had the same result and you submitted it 2 days before, then you will have a high grade, okay, in your solution. Well done. Okay, for the rest, we are going to work this later in motion. So refresh this because then we're going to be using it later. Okay. Any question? No. Perfect. We're going to continue now with the class. Let me. Okay.